Okay, today we are having our revision class. And let me just give you a very quick summary about what we've done in this topic. The topic, let's just call it graphs for the sake of today. So in graphs, there's a bunch of things. I'm going to start with the family of graphs over here. Family of graphs. Okay, we've looked at lots of different types of graphs in this topic, and so I guess in here you'll remember the hyperbola, you'll remember the truncus, you'll remember the exponential, and you'll also remember the circle. There's a few others, but I'll start with those ones. I just want to draw the general equation for each of these ones. Remembering the hyperbola is y equals a over x minus h plus k. The truncus was y equals a over x minus h squared plus k. Very similar to the hyperbola. The exponential was y equals, I'm just going to leave it as 2 to the x. We haven't looked at a lot of these ones, but we've looked at a couple of them. And then finally the circle, x minus h squared plus y minus k squared equals r squared being the radius. So we've looked at all of those types of graphs. Now a couple of the other graphs that we've looked at is we've looked at polynomials or quartics. So I'll put quartics down, and I guess we've also had a look at quadratics, and we've also had a look at cubics as well. We've probably the thing we've looked at the most is probably cubics, but we've had a look at all of these types of graphs. Now quartics, let me just write down the general equation again. There's two types, but we've sort of focused a little bit on this type. This one's called like the stationary point method, or that maybe the turning point method. X minus h to the power of 4 plus k. So quartics being to the power of 4, x to the power of 4. So now let's just have a look. Let's drill down on the quadratic side of things. Just draw a little line in here. Now actually, for both the quadratics and the cubics, we've had a look at the idea of the intercept method. Now, this is where there's a little bit of crossover between normal maths and extension maths. But let me just start on the quadratic parts first, part of the intercept method. We've had a look at using the cross method. Cross, how do you spell cross? There we go, the cross method. We've also looked at Mr. Aiton's method as well. And I guess we've also had a look at completing the square in this kind of section as well. Now all of these were when the coefficient of x squared was bigger than 1. So for example, I'll just make something up on the spot. I don't even know if this will work nicely, but 3x squared plus 2x minus 5. Now in normal maths, you haven't seen it when there's a 3 at the front here, but in extension maths, that's when we've looked at when there's a 3 at the front, or a number that's not 1, basically. Now that's for the for the intercept method, but for quadratics, we've also looked at graphs when they're in the turning point method. Okay, now that's the general equation for those ones is y equals a x minus h squared, I'm running out of room, plus k. Okay, so and from there we could sketch the graphs using finding the x and the y intercepts. I'll write these things down. X intercepts, y intercepts, and the turning point of hk. Again, there's a lot of crossover between your other maths and this maths. I guess one thing that I didn't mention for the quadratics intercept method is that I guess that the null factor law is part of this as well. Okay, And that's something, again, there's a lot of crossover between your normal maths and this maths. Okay, let's just jump to cubics for a second. Again, for the cubics, there's an intercept method, and I guess, you know, there's a bunch of other things that happen without cubic graphing. There's, you know, things like long division, remainder factor theorem, and all those sorts of things. But I'm just going to put it inside. Oh, hello. I don't know what that is. No, I don't want that, thank you. What I want to do is just have a look at the remainder factor theorem and long division, all those sorts of things inside cubic graphing. You don't always have to graph things, but I feel like if you know how to do it in graphing, you know how to do it out of graphing as well. So let me just try and manage my space a little bit better. So we've got here, we've got find a factor. Okay, so that's when you're subbing in x equals 1, x equals 2, x equals -1 to find out when the remainder is 0. Once you find the remainder of 0, that's when we use our long division. And hopefully you get the remainder of 0 when you're using long division. Then after that we fully factorize, grab the thing up the top, and multiply it with the thing that we divided by and factorize it, you know, that way. And then finally we solve, and this gives us our x-intercepts. Okay, again, I guess using the null factor law as well. So that's how you can sketch a cubic graph using the intercept method. The other thing that we've looked at for cubics is we've also looked at the turning point, or the stationary point. In fact, we called it the point of inflection for cubics. So I'll just put point of inflection like that, and this was, you know, the point of inflection is the bit that the graph does that. Okay, this bit here is the point of inflection, and that the general equation for that one was y equals a x minus, ooh, what's going on here? No, don't do it now. A long way away. X minus h. So many things are coming up on my computer. Didn't expect these. So, you know, a x minus h cubed plus k, very similar to the quartics, you know, turning point method, and very similar to the quadratics turning point method as well. A lot of the graphs end up being the same. Now, just a couple other things on cubics. I just want to say that you can have 3 types of cubics, or we've looked at 3 types of cubics: x minus b, x minus c. We've looked at that type of cubic. We've also looked at this type of cubic, and the final one we've looked at is when there's this type of cubic. As you can see, that one looks like the point of inflection method. Okay, so this one, I can label that as point of inflection. This second one here, it's got a repeated factor on the squared. I'm going to say that this one will have a bounce point. Again, I'm not sure if that's the technical language, but that one I'm going to call the bounce point. Whereas this one over here, oh, I've run out of room, haven't I? This one over here just cuts the x-axis at those 3 points. At 3 points, so it's getting a bit messy. Okay, so either cuts it 3 times, bounces at 1 point and cuts it another time, so sort of 2 times, or just the 1 time. It'll always cross the x-axis, and they always have y-axis as well, y-intercepts as well. Okay, one more thing that we've done, and it kind of fits over all of these types of graphs, and we sort of did it at the start, but you can actually apply them to any graph any time. And that's, I don't know if you remember them, but that's when we looked at our dilations, reflections, translations, or Dr. T. So we've got dilations over here. Let me give myself a bit of room. Dilations, this was the A, it affects the A, as you can see in front of here. A on the top of the hyperbola and truncus, but A is in front of all the other ones, you know, quartics, cubics, all those sorts of things. And this one stretches or squashes. I mean, the technical term is dilate, but sometimes we need to know what that actually means. stretches or squashes the graph from the x-axis. Okay, and hopefully in your notes you can have a look at some of those. If you can't remember in your notes, you can always go to your calculator. It'll also do something there. You know, just chuck in random numbers and it should work for you. Now, the other thing that we had was reflections. And this also affected the A, but this time it was when the A was negative. Okay, so you chuck a negative out the front of any one of these graphs that we looked at, and it will be reflected. Now, what this really means for us is that there's a mirror image on the x-axis. Okay, so everything that was above the x-axis is now below the x-axis. The x-intercepts won't change in this one, but the y-intercept will definitely change every time. And the last thing that we looked at here was translations, and there was two types. There was the moving up and down and moving left and right. I'll start with the moving left and right. That was the H bit. Now this is where it gets a little bit tricky, but I'm just going to write it down. X minus 3 means that it's moved 3 right, and X plus 2 means that it's moved 2 left. Okay, hopefully that's the way that you remember it as well. And then we've also got the K translation as well. So this one is, when we've got the bracket squared, cubed, whatever it is, then plus a number, plus 5, means it's moved up by 5. Maybe I'll write the word up. Ooh, got rid of my 5 as well. Up 5. And when you've got the same thing squared minus 2, that means it's moved down 2. Just snuck it in there. So that's pretty much what we've looked at in this topic. Obviously there's a lot of skills in there. There's a lot of just algebra that you have to do in that. There's a lot of mucking around with things. There's a lot of hello, not again. There's a lot of things that you need to take into consideration in this. But essentially, I like having that big sort of bird's eye view. That way I kind of know where I stand when I'm doing all of this sort of stuff. So thanks for listening, and hopefully you enjoyed this topic and the revision for it as well.